Hello everyone, I hope you can hear me. If you can hear me, give us a shout on the chat window so that you can know and we can get started. Good evening for the folks joining from India, and good morning and good afternoon for the folks from the rest of the places. Thanks for taking the time on your Friday evening to spend it with us. We have prepared quite some interesting topics to discuss today, and I'm happy that you decided to join us for this interesting session on AWS Lambda and how to do async and synchronous calls with us. So what I'm going to do is I'm just going to wait another 10-15 seconds and see if some more people join, and then we can get started with that. So before we go ahead and get started, just a quick feel of the room to see what kind of people we have. On your chat window, can you just type in, like, say for example, if you're already working in AWS and you're running production workloads, yes or no? Like how many people are running production workloads in AWS right now? Nobody? So I assume everybody knows how to use the chat interface over there. Okay, there's a DevOps engineer, and there are a few people who say S on prod, and a few people who have joined and who are running some production workloads and basic. Have anybody or is anybody running Lambda functions or serverless, or tried anything with serverless and Lambda before? Okay, there is I assume there's a couple of S's for Lambda. Fantastic. So we have a mixed crowd of people who are running some workloads in production, and some people who are running Lambda, some people are not running, and we have a mix of everything here. That is nice to know. Okay, it is already 1 minute past the time, and we have quite a few people joined. So in the respect of everybody's time on Friday evening, let us go ahead and get started. So before we go ahead and get started, what I want to do is I want to introduce myself, and then let us go ahead and see what is the session is about, and then we'll dive deep into that. So first, about me. If you have been watching a Valaxy channel for quite some time, you might be familiar with my voice. If not, I'm Kumar here. I'm a solutions architect, and quite a lot of the AWS videos that you see in the Valaxy channel are made by me. And me and Shankar work together to bring up all this nice content for you. We listen to all the comments and feedback and try to keep it entertaining and share our knowledge wherever possible. I'm also an Udemy creator. I have multiple courses on Udemy. You can go ahead and check them out. The link must be somewhere in the description, or it might come in the chat window. And finally, all my open source work is available in GitHub. You can go ahead and use them for your own use cases, either for doing automation or doing security or just knowing more about AWS. So we have different kind of resources available in the GitHub. So that is about me, and some housekeeping rules about this session. Since we have different kind of user groups available here, so here are housekeeping rules. First thing is, this session is going to be somewhere between intermediate level to beginner level. We are not going to cover why AWS, what is AWS. We are not going to cover what is EC2. We are going to assume that you already have some amount of AWS knowledge, and we are going to assume that you know what is the Lambda functions and what is API gateways. We will touch upon them, but not in detail. And if you have any questions, please use the hashtag #questions before you type them in the chat window, so that our moderator can easily pick them up and feed it to me so I can get them answered. Likewise, if you have any suggestions or any topics that you want us to talk about, or you want to recommend something, then use the hashtag #suggestions in your comments. It can be in the live stream or in the generic YouTube comments. Please use them so that it is easy for us to housekeep the entire conversation and keep it healthy for everybody. And we will try to pick up questions which are relevant for a larger group of audience instead of a specific ones. If you have a very specific related to your project or related to your work or related to something that you want to learn, then you can engage our professional services by email, or you can just talk to us through phone. So that is about me and the session. And for this session, we are going to do a live code. So if you are wondering where I can get the live code, as I said in the beginning, the code is available in my GitHub, and the link will also be added in the video description once we finish up a demo here. So that is what we are going to see now. So what is serverless? Before we go ahead and see asynchronous and synchronous, let us talk about what is serverless in basic. So when you're talking about serverless, you are not going to manage any servers. Quite often this topic comes, serverless also has some servers in the backend. Somebody is running that for you. But the most important thing that you need to remember here is you are not going to do that, whether you're running a Lambda function or a Fargate container service, any of the managed services. You are not going to provision any infrastructure. As long as you need more events to be invoked, more process to be done, the cloud provider will handle that for you. So you're not patching them, you're not managing the security of those instances, and you're not scaling up and down. So you get automatic scaling, especially when you're talking about the Lambda functions. It gets invoked whenever there is an event. So you have one event, you get one Lambda invocation. If you have 100 events, you will have 100 invocations. So you are getting automatic scaling, and you are not paying for any unused capacity also. So that is where the automatic scaling comes in. And since you are not having unused capacity, you're also not going to pay for unused capacity, obviously. So you're paying only for what you are using. So it is very much like your utility pricing. You pay for the value that you consume, just like an electricity or a mobile plan that you have. So you consume some things and you pay for that. And since the cloud provider is taking care of the infrastructure of providing the compute capacity, storage, and availability, you have all this high availability and security that comes along with these services. So you have high availability and security, and you don't worry about provisioning. So that allows you to automate quite a lot of things in a high pace. So this is what serverless in short offers you. When you are talking about serverless, there are multiple ways of engaging with a serverless architecture. For example, you can invoke a serverless function in a synchronous way, and you also can invoke it in a very asynchronous way. So let us go ahead and understand what is this synchronous request means, so that we can understand how it impacts our daily life. So when we are talking about synchronous request, in event-driven architecture, it is called as synchronous commands, because everything happens as a flow, and one service is dependent on the other service, so it is treated as commands. And let us say you as a client initiate that request. Once this request is initiated, what happens is you are going to, let us say, to a banking page or an e-commerce page. You open the e-commerce page, and then you initiate your payment transactions. So your browser is initiating the request, and it is calling the payment gateway. Let us say in this case, on any e-commerce site like eBay or Flipkart or Amazon.com or anything like that. So you have your service A, and this service is going to go ahead and initiate the payment gateway. So there is some amount of time involved here, and this request is going to be forwarded to your banking transaction. So it might be an bank A for a person and a bank B for another person. So it can be different banks that happens. So we are going to call this service on the back end, and until this transaction is completed by the backend service, because the bank has to verify whether you have enough credit in your account, whether you have enough balance in your account, so that the transaction can succeed or fail. So until this time, your e-commerce website is waiting for the banking transaction to complete. So basically the entire request is blocked, and you cannot do any other process during this time. So this is what is a synchronous block means. So in this case, you can see the service A is waiting for the service B to come back. So once a service B completes its transaction, then it feeds back that event back into service A, and service A will do the remaining thing. For example, in an e-commerce case, once payment is successful, then your order is beginning to be shipped, or it goes into the warehouse so that where it can get shipped. So this is what the entire synchronous transaction happens. So your client initiates the request, service A gets the request, and then it goes ahead and calls service B, and then the service B completes the transaction, and everything else waits for that time, and then you go back and complete the remaining part of the transactions. But when it comes to asynchronous events, what happens is, think of a transaction like, for example, you are doing something in Gmail. That might be the quite easier use case, since everybody might have some email access or using an email client. What happens is you do an delete of an email, or you go ahead and drag them into a folder. What happens is the request is received from your client. In this case, your browser is sending the request to service A, and service B will be notified saying, hey, this user wants to do this activity, and that information request has been received, but the service A will not be blocked until service B completes its transaction. It will be released back, so service A can do something else. In the Gmail case, you can just drag and drop multiple emails from one folder to another folder, or delete a lot of emails, and then immediately you should be able to go ahead and perform another operation. Your browser does not stop you from do that. But if you try and close your browser, you usually get a notification saying, hey, this operation is not completed, I have not got a return back from service B. Do you still want to go ahead and close your browser? So go ahead and play around with this. So there are many examples of asynchronous transactions. For example, you upload a picture to Facebook or Instagram. What happens is they take the picture and then they start processing it into different formats. Particularly in YouTube, if you're uploading a video, they go ahead and convert it into different resolutions so that different devices can access those videos in different formats. So that is going to be an asynchronous upload. So once the upload is completed, the backend processing is going to be completely different, and the user will get a message saying your video is getting processed, or your image is getting processed, go ahead and do something else. So this is what an asynchronous request looks like in real life. So if we want to do this as an example, if we want to do this, how can I test it, or where it is really useful in real world, can I test it? So I have built a couple of architectures so that we go ahead and deploy it into our account and see how we can do this. So when we are talking about a synchronous Lambda invocation in AWS, so this is how it is going to look like. You have your users, and your users are going to send an synchronous request. So I have written a very simple Lambda function, and this Lambda function is what it is going to do is, if you give a number like say for example 3, and it will give you the square of that number. So in this case 3 will become 9, and if you pass on 9, it will give you 81. So you are going to square that number and give it. So the larger the number, technically it should take more time, but since Lambda is quite powerful, you are going to get a response immediately. So I added some delays. So when you do a synchronous request, Lambda is going to take some time to process it and give it back. So in this case, the request from the client hits the API gateway, and the API gateway is going to forward that request to a Lambda function. And once the Lambda receives that request, it is going to process it, and it is going to send you back and response with the square of that number, and it will also give you saying this is the IP address and some other metadata like which client invoked that request. So this is the synchronous part of the invocation. So when you are talking about asynchronous, we are going to have a very similar flow, but the one small change is the Lambda will immediately send a response. The API gateway will immediately send a response back to the client saying that we have received your request and we are going to process it. So the flow is going to look something like this. We have a client, and the client is creating an asynchronous request. There is a typo there. It should be asynchronous request, and the asynchronous request is reaching the API gateway, and it will go ahead and invoke the Lambda function. And meanwhile, the Lambda function is going to process it, and the API gateway will return back the received event, And once the Lambda completes the transaction, it is going to store the information into an SQS queue so that somebody can go ahead and see what is the completed product or the completed output of that Lambda function, and you can go ahead and retrieve this. So this is a simple architecture. What I'm going to do now is I'm going to show you how you can do this in your own account without needing to know how the lot of coding works. So you don't have to write any code. I've written most of the stuff and you should be able to deploy that in your account and try it out. So let us go ahead and get to my AWS console and see how we can deploy this in our own accounts. So let me switch my screen to my AWS console here. So just give me one moment. I'm just trying to switch my screen here and then let's get started. So on the left hand side, what you see is the GitHub article where all the code and all the information that you need is written there. You can see the entire description of what is an synchronous command flow looks like and what is the asynchronous command. You can go ahead and read them at your own pace to understand and cement your knowledge of what these flows are looking like, including the architecture that is somewhere down here. But let us go to our console and see this. So for deploying this architecture, we need a machine which can interact with our AWS account. Typically, I would use my own laptop, which is configured with all the tools and dependencies, but sometimes I get a feedback saying, how can I do this? A lot of things are broken. So what I'm going to do now is I'm going to boot an Amazon Linux machine in my account. I'm going to use that as a developer machine. So this experience can be reproduced by any of you who is watching there without any difficulties. So the first step is launching an EC2 instance. And one shortcut that I have found very helpful is launch templates. This is nothing but all the EC2 configurations are rolled into one particular launch template, and that you can be reusing again and again. For example, you can see here there is a couple of launch templates I have, and I'm going to use this Amazon Linux tool. So if I just go ahead and click on this, and you will find the AMA ID and what is the instance size, what is my security group. Typically, I have not enabled any security group ports other than port 80 and port 443. So just basic configurations, go ahead and try it. The best part is I just go ahead and click on launch template from instance, and it is going to ask me how many instances, and all the basic informations are there. Just click on launch instance from template, and I will have an instance running in my account. So it just makes it very easy for me to launch instances really fast. So one important thing to note here is I am not going to connect to this instance in the usual way of using PEM keys and PPK keys, because once again the feedback was people don't know how to use some of those tools like a PuTTY and MovaXterm, and the questions keeps coming saying I don't know how to do this. So to avoid that, what I'm doing is I am using an Amazon Linux machine. The reason for that is Amazon Linux has something called as a built-in SSM agent, and let me go ahead and open this role. This is the IAM role attached with my instance, and my IAM role has two permissions. One is admin level privileges, because we are going to launch some CloudFormation templates. So one is administrator access, and another access is let me see if I can expand this one. Looks like this is something called as AWS Amazon SSM managed instance core. So it will allow me to connect to my instance through my browser. So let me just close this. If my instance is up and running, what I can do is I'm just going to click on connect and click on session manager. And if my instance is up and running, my SSM agent is also up and running, my permissions are also there. If three conditions are met, then I can just click on connect, and through the browser itself I should be able to get connected to my instance. So you can see here it by default it gives me an shell prompt. What I can do is I can just go ahead and change it into my bash prompt, and I can also sudo and become root user also, so that I can install some packages and run some commands. So we got our machine running. So this is going to simulate our dev environment. And just to make sure that this is a live demo, I'm going to open my CloudFormation, and let us go to my Lambda as well. So you can see here there are only two stacks. One is a CDK toolkit and then the backend stack, but this is nothing to the stack that we are going to deploy now. So let us ignore them for a moment. And likewise in my Lambda functions, as of now, there are no functions. So all the instructions of how you can do this in your account of creating an asynchronous architecture in your account is written here. So if we just go ahead and see, what we have done is a prerequisites. We have an AWS CLI configured. So just to be sure, if you want to be absolutely certain that your AWS CLI is working, all you can do is AWS S3 LS. It is going to list all my buckets. So remember, I have given admin privileges. You can go ahead and restrict them as required for your environment. So my AWS CLI is working. And next is making sure CDK is installed. For CDK, we need Nodejs or Node. So I don't think so. I have Node here. npm-v should not work. So what I'm going to do is I'll put this link also in in the description, so you can go ahead and run this. This is also setting up Node.js on Amazon EC2 instance. So I'm just going to blindly copy paste them because these instructions have been tested to be working, and we don't have to worry about whether these are the right instructions or not. So once we have this also up and running, we should have our npm version. So I'm going to check npm is running. So npm is running. So the next step is installing AWS CDK. So let us go ahead and do that globally. AWS-CDK. So this is going to take a minute. So CDK is working. So let us do CDK hyphen. Okay, I think it is CDK hyphen version. Yep, we got our CDK also installed. Let us go back to our GitHub article. So we got our CLI installed and configured. We got our CDK installed and configured. Next is making sure we have Python 3 and pip environment. So I'm just going to make sure we have those two instructions. So it is installed already. So that is why you have a prompt coming back immediately. So let me just move it up the screen. No, looks like I cannot. So let me just install Python pip. That is also installed. And let us make sure we have virtual env also. So once we have this, the entire code for this repository is in this URL. So we can git clone it. So we will get it in our dev environment. So let me clone my repo here. So we got it here. So you can see here, this is the application repository that we have cloned it locally to my account, and we are going to use one second. Okay, looks like there is a request to increase the font size, but this being a browser, this is going to be slightly difficult. Let me see if what is the font size that works for everybody, because we are using a browser prompt, and if we are using a putty or a terminal, it might be much helpful. But let me see, let me try. Because the font size is not directly controlled by me, it's just a browser, so I just have to play around with the zoom levels, unless I play around with my bash profile and increase the font size, which I don't want to do right now. So anyway, getting back to what we were doing, we have cloned our repository into our development server, and you have all the necessary files. The next step is preparing our virtual environment. So what this is going to do is, under requirements file, usually you will have some dependencies of libraries that are required for running this architecture. So we are going to install those dependencies. Remember, we have already done this, so I'm just going to go ahead and copy this. So this is the command. This is pip install -r requirements txt, that is going to make sure that all the dependencies are getting installed in your local environment. So there you go. When I press enter, you can see all the dependencies are getting installed. So while this is going on, so I'm just going to see if I can increase my font size a little bit more, but let us try that one more time. Okay, this is already too big. Anyway, so the next step is we are using CDK as our deployment. You can use it in Terraform or any other coding terminologies or platforms that you want to use. But since we are using CDK requires and Bootstrap. If I go to my CloudFormation stack, since we have a different zoom level on one browser, so automatically it picks it up here as well. So this is going to create my CDK toolkit stack, just to show you what happens when I run the CDK Bootstrap on my terminal here. It is going to check whether my account has that default stack. It is nothing but going to create an S3 bucket so that my CloudFormation templates and everything that are there in this code will get copied to my account and get deployed. So if I take you to my CloudFormation stack and take you here, let me see if I can fold this one. Under resources, you can see here there is one staging bucket is created. So that is what this Bootstrap command is going to do. And next is making sure we are having the stack which is up and running. So let us go ahead and do a CDK ls. And once we have the stack that is synthesized correctly, what is going to happen is we are going to deploy our complete architecture into AWS now, which is going to deploy as an API gateway and an Lambda function, and it is going to configure the Lambda function with the appropriate IAM roles, and it will give us the API gateway URL also on screen, which we will use for testing in a short while. So it is getting deployed. So if I take you back to my CloudFormation service, what I'm going to do is I'm just going to reset my zoom size so that it is easier to watch it here. Let us go back to stacks, and you can see here I have my serverless async Lambda API stack getting deployed, and under events you have all that information. But let us go to our resources. So we got our SQQ Queue created, we got our API gateway created. So let me walk you through API gateway. So we have our backend API. This is for the campaign stack. That is another stack that was deployed in my account, but this is the API that is getting deployed for our particular Lambda function. I've called it backend. In the previous example, you remember service A and B. So this is what one of the services backend looks like. So if I take you to my Lambda functions, there should be one Lambda function which is going to create a square of one particular number. So if my stack is completely deployed, I should be getting the URL on my screen. It is still working through, about just one more resource pending. So you can see here, it gives me the URL on my screen. So I'm going to put this URL on the chat window. So you can see here at the end of your URL, you see a number. So you can do something like a number 2 or number 3 or something like that. You can change it on your screen. You should be able to get a response, and the response usually takes about 3 minutes approximately, so that we know that it takes some time. So I put it into the browser, so go ahead and try it. So I'm also going to try it on my screen. If I go ahead and put it here, say, let us say 1000 here, and it is apparently there seems to be an error. So let me Remember what I've done is I have restricted the Lambda function to execute only once per second, so that it is called as the throttling or concurrent executions, so that too many executions does not happen at the same time. If I go to my Lambda function here, and I can show you that this is as an security mechanism, I have made sure the Lambda function is not executed too many times by somebody. So you can see here on my screen, I have my reserved concurrency of 1 per second. So I'm just going to do it as unreserved account concurrency, so that because too many people are trying it from the browser, everybody's clicking it at the same time. So obviously there is going to be some errors. So let me just refresh my screen again, and we should get a response now. So you can see here it is working now when I just type in 1000. So let me just go ahead and take a much simpler number saying 5. So what we have done is, this is a synchronous request. If I go back to Postman, for example, Postman is a tool that you can download into your account and use it. So under Postman, you have this plus icon. Just click on this one and then put in the URL here. So why I'm using this tool is it measures the latency of how much time it takes for the request to be satisfied by my backend, and gives you that numericals on your screen. You can do it on a browser developer mode also, but this is much more nicer way to look into it. So I'm just going to check the square of 9. And when I press enter, what is going to happen is my Lambda is getting invoked, my API gateway is waiting for the response, and it comes back with hand. You can see here there is a status of 200, and then the time taken is about 3.53 seconds, and you can see the breakup of the different time that is taken. But we don't want this, right? We don't want the synchronous request where user is waiting for some backend to process. We want to inform the user saying, hey, we got your request, we will give you the response when the response is ready. So that is what an asynchronous request means. So how do I make an asynchronous request here? If I take you back to my browser page, you can see here. So what we have done is in the testing section, we got our URL, we tested it just now, and we got a similar response like this. And we tested it with Postman also, and now we want to test it with an asynchronous request. When we want to test it with an asynchronous request, we want to add a particular header to our request. So the header looks something like this: an invocation type event. You can use a curl command in your terminal, or you can use a tool like Postman to do this very easily. So what I'm going to do is, I'm going to do an asynchronous request through my Postman tool. So let me just copy this. Invocation type is event. I'll show you later how to do it in curl also. So let us go back to our Postman tool. So I'm just going to open another tab here. Okay, under headers section, I'm going to add a header called as invocation type, and the event goes into the value without this colon. And let me copy this URL here. So let us do it for 9 only. You can see here for 9 it was about 3.53 seconds. So let us see how much time it takes for an asynchronous request. So let me click on send, and you can see here it is, I got a request from the API gateway almost instantaneously. It just took me about 154 milliseconds only to get a response. And the most interesting thing is, when I do this, it says the asynchronous invocation is true, and then the message is event received, check your logs or your queue for status. If you remember, I set up an SQQ queue to get the response for 9. So what I can do is let us just go ahead and say particular number so that we can check in the logs. So what I'm going to do is, I'm just going to do a very big number, something like so that it is unique, and we can go ahead and check in the SQQ queue also later, and also in the logs. So this is how asynchronous request works. As I told you, I'm going to do this once more in curl command also, so that we can see, or if you guys want to do it in your own terminals without Postman, you can also do that as well. So for the command for curl is something like this. So for this, I need the API gateway URL. So let me just pick up the URL first. So this is the URL. and let us go to the OS terminal. So I'm just going to paste it here, but we need to paste it with the URL. You can see here, I need to set it up like this so that it is easier for us to reuse the URL. So I'm going to call this way. I'm just going to copy this again, and instead of 5, let us use something like a 55 here, and this is going to be my URL. So I'm going to say curl hyphen, you can do -h, or we can do the URL name first and then we can do that. By the way, all these commands are available in the GitHub article, so you can go ahead and use them, just copy paste them. So I'm missing a curl there. So you can see here in command prompt also we got a very similar response. So you can do this either in Postman or in any terminal that you have access to. So if we go back to our queue, we should be able to retrieve this square of 5 and then the very big number. So for retrieving the square of these from the queues, we have the commands here on the terminal. So if I go take you back to my browser here, if you just scroll down here, it talks about how to retrieve the messages from the queue. So I have written the commands also so that you can check it out. So let us go ahead and set these variables. So what this variable is basically doing is setting my queue name. If you deploy this stack, you will get a queue of this name. If I show that in my account, let me go to SQQ. Let us open it here. So go to queues. I should be having one queue. You can see here there is a queue with about 3 messages. It was from my terminal only. I think nobody else have added a asynchronous request here. So the way that we can do is we can go ahead and retrieve these messages one by one using these commands. And of course, this is my account, so you will not be able to retrieve it, but when you deploy it in your account, you should be able to have the credentials to interact with this SQS queue and retrieve those messages. So what I'm going to do now is I'm just going to retrieve the messages one by one from my terminal. So let us go back to our OS terminal and set these variables. So the first step is nothing but setting the variable name to async get square function destination queue, and then we are getting the queue URL because every queue has a unique URL, and once we have that unique URL, what we are doing is give me the message one by one. So let us go it once, and here you have the square of that very big number. You remember this is the big number that we sent in earlier as an asynchronous request, and this is the response. This is the square of that number. So if I go ahead and execute the previous command one more time, we will be getting the square of 5 or some other number we gave it, 55. Yeah. So let us try it because we have 3 messages in the queue. We have retrieved 2, and let us go back and retrieve the third one also. This should be for 5, I think, or I did it twice. So I'm just going to try and retrieve it again. There should be one for okay, I think there are different people. Okay, we have retrieved all the messages now. Fantastic. So in short, this is how asynchronous messages works. So if I the best way to understand is the Postman, because it shows you a very clear difference of how soon you can get a response from your client. Earlier we had a response time of 3.5 seconds, and when you move your architecture to an asynchronous response, you get 156 milliseconds. Think of your banking transactions or some other transactions can be done asynchronously. Maybe not banking, maybe something else like say you are sending and uploading a picture and you are getting a response in 150 seconds, 150 milliseconds instead of waiting for 3 seconds, then it improves your application experience for your users because they are not waiting for something. They can go ahead and do something else. So this is why I really like asynchronous architectures in my production environments, in my accounts and my customers. I go ahead and talk about these things to quite a lot of my customers, and whenever they get to know of these features, they are really happy to know about these features, and they want to know how to implement this. So that is why this entire architecture was written, so that the people can go ahead and use them in their own environments. As a starting point, you can just go ahead and deploy this and play around with your own account and see how you can customize it and do it also. So that is why I've done this. In short, it is very simple to use. I've seen people adopt it in 1 week or 2 weeks, and it improves your end user experience basically, because they are not waiting for things, and it reduces your latency of your applications as well. So that is all I had for today. The most important thing is you are no longer just listening and learning things. You have a stack which you can deploy in your own account and do it in your own account in your own free time, and learn about these advanced architectural patterns of doing asynchronous request responses. So you just go ahead and do it in your own accounts. I would highly recommend you to do that. And remember, this entire architecture is built on using the tool called AWS Cloud Development Kit. And if you are interested in learning more about this Cloud Development Kit, there should be a link in the video description. You can go ahead and check out more about this tool and how you can leverage these tools for deploying advanced architectures in your account. So that is all I had to offer. If you have any questions, or if you want to know more, put them in the comments. I'll try and answer them now. So that is what we are going to do in the rest of the time for the day. So let me quickly go ahead and see what questions we have. So as of now, I seem to see the only question that I have on the screen is about increasing the font size, but that is something that a tricky thing to do, because I'm not using an putty terminal, or I'm not using an what do you call it, mobile XTerm or some kind of a terminal to increase the font size, but it's a browser. So, and if you are using a laptop or a screen, you should be able to zoom in. So there is a question. There is an attempt to do a hash, but please do add the hash question. It is not just the hash. So it is very easy for our team to find out what are the questions and answer them. So let me read the question here. Can call REST API from mail server also to a Lambda function? As long as it is not from within a mail, but you can do that, yes. It should not be too difficult, as long as Lambda is an event invocation response mechanism. So if you can send an event with appropriate privileges, then Lambda gets invoked and then you can get a response. So even if for sending mails also, we can do that. So are you using Apiary? If you are talking about tools like Apiary or APG, well, it depends upon the organization. Personally, I'm not using it. But if your organization or your team is familiar using those kind of tools, then you can go ahead and use them. It depends upon what you want, right? Whether you want logging, throttling, management, and all those sort of things, then you want to have a tool for managing them. So you can look at API Gateway as default features. If that is not enough to satisfy your requirements, then you can go ahead and use other tools to satisfy them. So how would you secure our Lambda API? Well, there are tons and tons of ways. This is one of the things that I want to talk about here. We have some fantastic automation on securing API to API communications, and we can do a demonstration on that as well. So that is one way. You can use OAuth. You can also use API keys. so that you can distribute your API keys to your trusted parties and they can use those API keys. Or if it is within your own account, everything is within your own network boundary, then you can have something like a private endpoint, so that requests coming from certain IP addresses can only invoke your APIs. And you can also restrict it based on IAM credentials or any kind of an authorizer that you can write. Multiple mechanisms, network, IAM, OAuth, so depending upon how you want to do it. So that is how you can do API Gateway security. And there is a question about, can you tell some Lambda industry based use cases? There should be a repository called AWS-real-time use cases in my GitHub. Go ahead and check it out. There is plenty of them. There's another question. It is a hash question, guys. Hash question, just not the hash, so that I can easily look at them. Just write hash questions. How does security provided for the Lambda application? Yeah, just now we just spoke about it for API Gateway. Similarly for Lambda is event invocation, right? So who can send that event? So if I can take you back to my terminal, let me see if I can take you back to my Lambda console. So if I take you back to my Lambda here at the beginning of the Lambda function, you can see here, this is the trigger. So in this case, I have configured my API gateway to trigger my Lambda function. So that is this Lambda function is in my account, and if the invocation is not coming from my API gateway, this Lambda is not going to be triggered. So that is how you secure your Lambda function as the first step on invocation level. But if you want to secure it within your own account, then you can have authorizers on your API gateway also. And also in your Lambda function, also you have something called as an resource policy. So you can see who can invoke your Lambda functions by attaching a resource policy for your Lambda functions as well. So there are multiple ways you can secure your Lambda functions. So let me go back to my screen here for a Q&A. I lost the track. Where was why we were talking about security for Lambda applications. That is one simple way. There are many ways. Of course, you will have invocations, Lambda security policies, and remember the concurrent policy that I also set, so that you don't have a runaway Lambda. So it is not just security at one way. You have to do security at all layers and security at depth. So if you want to make sure that your Lambda is getting invoked only once per second or only a certain number per second, then you can go ahead and add throttling as well and those sort of things. Thank you, Mr. Telugu Techies. Thanks for the good demo. Fantastic. So there is a question. Can you explain in short Elastic Beanstalk? I assume it is Elastic Beanstalk and AWS Lambda. Well, Elastic Beanstalk is where you give the code and Amazon figures out whether you want application servers, auto scaling, load balancers, and all those things, and provisions them for you. Whereas Lambda is event-driven architecture. You don't have any servers. You are giving Amazon the code, and you telling Amazon that I want to have this much of memory for my Lambda function, and Amazon automatically provisions the necessary compute capacity for you. For example, in this case, if I take you back to my console here, so in this case, I have given my Lambda function the least of 128 MB of memory. If I go ahead and edit it, you can see here I can just increase it all the way up to about 3 terabytes of I'm losing my mind, 3 gigabytes of RAM, and if I'm not wrong, the maximum is about 15 minutes. So that is the maximum runtime your Lambda function can be. So you have these limitations, but you don't worry about scaling them. Whether it is 10 requests per second or 1000 requests per second, your Lambda function will be able to meet those requirements. Whereas in Elastic Beanstalk, you still have to manage your EC2 instances, because if there is an update, until recently there was no easy way of doing a rolling upgrade for your Elastic Beanstalk. So these are different type of compute environments where you choose event-driven architectures and where you have an complete application binary that you want to run in virtual machines. That is what Elastic Beanstalk offers for you. So let me just quickly find out where we were in the Q&A section. Mr. Vigneshwaran, if it is there is a question about Lambda authorizers. So if it is required, we can do another session on another day, because it is quite an advanced topic and we need to see how many people will be interested. For people who might not be familiar with Lambda authorizers, it is one of the way of securing your Lambda functions, whether it is a custom authorizer or using an OAuth authorizer. So you can do it different ways as well. So are there any sessions related to step functions? Well, that is an interesting question. Depending upon the demand, we can do step functions also, not a problem. There are plenty of fun examples that we can do for step functions. There is one in my security automation course. I have used step functions quite extensively for remediating security breaches. For example, let us say your instance is having a breach, then you can trigger a step function which will take a snapshot and update the firewalls and also isolate that instance role as well. So you can use a step function for doing all this kind of things. So we can do a demo on that as well if required. So in the last few minutes, we will do a quick poll of seeing what topic is popular so that we can choose the next session appropriately that satisfies a lot of requirements. So there is a question from Rajesh Singh. I'm happy that someone is using the hash question, so it's easy for me to pick up. Will the Lambda is integrated with IoT core or implemented in IoT devices? Well, it depends on different things, Mr. Rajesh Singh. Whether your IoT device can support green grass, then you can go ahead and deploy your Lambda functions on the green grass device itself, or you can forward the event from your IoT device to your local relay through an MQTT bridge, and then you can process those events in the cloud in the IoT core. So it depends upon how much compute your device has and how much time that you have to process that event. So it depends on those factors how you want to do it. Both the possibilities are available for you. Okay, there is a very interesting question, although it is not hash marked as hash question, but I will answer them. Is Lambda is expensive to practice? This question keeps coming up in our channel quite often. What is the price of this? What is the price of that? The best way to answer is go ahead and check the prices for that service, because we don't know what is your use case. Whether you are, say for example, I personally can run an EC2 machine in my account and terminate them after I finish done, and then I will not incur a single penny. But if you are forgetting to do cleanup in your account, you are going to incur cost for the same. So it is free for one person, it is not free for another person. So it depends upon what you are using it for. If you are being careful, quite a lot of services can be done free. So go to AWS Free Tier and understand how the cost works, and then go ahead and have fun with them. So in short, quite a lot of things that you see in Valaxy, either from me or Shankar, is done in the free tier. Quite a lot of things. You would be surprised at the amount of things that you can do with the free tier if you're conscious about what you're running, how long you're running, and understanding the pricing mechanism. So go ahead and do read the pricing page. So nobody can answer that question except for yourself. And it is pretty much simple. You have this cost calculator also, and a lot of use cases of how the cost works. So go ahead and try it. And basically the architectures that I've shown you today, and I have tested this demo with at least 5 to 6 people, all of them deploying 2 to 3 times. So that is like 20-30 deployments, and none of them incurred any cost, for example, because I can do that also. Let me go back to my browser page. So if you guys can see my browser page, and we got our session automatically terminated. This is one good thing I like about SSM Session Manager, because it automatically terminates your session and you don't have any security problems also. Let's just go ahead and connect this. So I'm just going to connect to my dev machine. Basically, that's what it is. Usually you will have this dev machine in your laptop or in your desktop. So let me just go to bash, and I think we have serverless cd serverless. I think, I don't know where I cloned the repository. Oh, I was in root, so let us go back to root. So yeah, cd serverless, and I'm going to activate source. So what I'm going to show now is nothing but how you can clean up your account. We have deployed so many resources, so how do you easily delete them? Because for example, if I go to my CloudFormation and show you in my resources section, you can see here this particular stack has deployed my SQS API Gateway, IAM roles, and then API resource, two resources, one for synchronous and another non-synchronous, asynchronous, and then roles for my Lambda function. There are quite a lot of resources. So instead of going ahead and deleting it here, I can simply just, if you're using CDK, instead of logging into your console, you can just come here and say CDK destroy, and it will ask you, do you want to delete everything, especially if you have IAM roles and data created that will be stored. Then just go ahead and say yes, and the CDK is going to clean up your account of all the resources. And if there is a problem of cleaning up your resources in your account, it is going to give you an error message also. And I have written this automation in such a nice way. For example, Lambda functions will have some logs, and all those logs will also get deleted once this stack is deleted. So you can see here already, when I just click on my Lambda function, the Lambda function is gone because it is deleted already, and my CDK stack is going ahead and making sure there are no resources in my account. So basically, this is how I ensure that I don't incur cost unnecessarily when I'm learning some things or figuring out new services. First thing is I go ahead and understand the pricing page. Then I just go ahead and make sure that I'm not running things for too long time. So moving on, is another question. How can we search on Udemy platform? It depends upon what you're searching for. If you're looking for my courses, one of the course must be in the video description. If not, I will add the other courses also in the video description so that you can go ahead and find them. And one of our team members have already put my LinkedIn profile, my Udemy profile, so all the courses must be there, so you should be able to find it. So fantastic, thanks for that. And there's a question, Mr. Mahendra Chaudhary. So it is a hash question. We are getting lazy there. Without EC2 instance VPC start, what does it mean? If you care to elaborate and learn term typing, I would really help that. Thank you, Mr. Rajesh Singh. There is one last question. Before that, I want to do a quick poll. How to share code across functions? Depending upon where you have share your code, or there is a possibility of using Lambda layers also, if you're looking for that kind of an scenario. So Lambda layers can help you to share your code across multiple functions. So if before I wind up for the day, so if you see, if you're seeing my screen, you can see here CDK has completely destroyed all the resources in my account and made sure my account is clean as I started the day before this live demo. So this is how you keep your account also clean, so that you don't leave resources here and there and figure out why some things are running. So the last thing that I want to talk about or ask you guys as a question is, use the hashtag hash suggestions. What do you like to see in the coming week as a live demo, either in AWS or in DevOps, or in something else that you have in mind? So go ahead and type it in hash suggestions So we will take some feedback from you guys and see how we can do this next week, so that you guys are also learning something interesting and we guys also have some fun sharing it with you guys. So put it as hash suggestions and type them either as a comment to this video or as a comment in the live chat, so that our team members can pick it up and we can process it later. How to map EC2 AMI snapshots and volumes. There are plenty of, just go to Valaxy YouTube channel and search for AWS automations. I think I have a screen for that. So if you are able to see my screen, this is the Valaxy channel page. I'm just waiting for it. So you can see here on the right top corner, there is an about button, and next to that there is an lens, which is having the DevOps plus AWS. If you have any topics and you want to see what is Valaxy's offering in that topic, just go ahead and type them. In this case, I have searched for AWS and DevOps. If you're looking for AMI, just go ahead and type in AMI and you will get some search results, and you should be able to use those, because these topics on how to take AMI backups, how to take snapshots, how to clean them, how to launch in Jenkins server, how to launch a Kubernetes, and or how to launch it in GitHub, all those sort of things are there in the accounts. There are questions like what is MobaXterm also. So just search them, you should be able to find an answer there. So suggestions, so a couple of them are there. AWS IoT Core. It's a great topic, Rajesh, but unfortunately we don't have another camera that can show an actual IoT device. We can simulate it or emulate it from an EC2 server, but we will see how to do that. Vertical scaling possible in Lambda, yes. Suggestions, step functions, code artifacts. Code artifacts, I think, yeah, we can do that with Nexus or SonarQube. DevOps related services will be good. We would like to be really specific because DevOps is not, my DevOps is not a DevOps for somebody else, because for me DevOps is code commit, code deploy, code build, code pipeline, code star. So that is what I define as DevOps. Sometimes for some people it is Jenkins, GitHub, or Ansible, Kubernetes, things like that. So we have a couple of suggestions. Fantastic. We can brainstorm on that. Docker Swarm with load balancer and use Docker Stack. Oh God. Which world are you in, Mr. Suraj? Let us get to the cloud. Let us get to the cloud. Let us get to the cloud. Okay. We are almost on the clock, so I'll just wait for a few more minutes. If there is any other interesting questions that can be answered, I can answer them. If nothing else pops up, then we can wind up for the day. Suggestion for Terraform use cases in AWS, yeah, we can do that. Suggestions for AWS EKS, yeah, why not? Fantastic. Thank you. So I think we have run to the close of the day. Thanks everyone for taking some time on your Friday and joining us. And we will look into your suggestions, and we will come up with another webinar quite shortly, maybe next week or after that, after vacations, so that we can share and have a good time on another Friday evening. Once again, thank you very much. I'm going to end the session for the day and see you in the next one.